Academy? You guys have your papers?
Yeah.
You have your note page? Your note page? If you don't use it, no worries. It don't bother me at all. But
Which page is the handout?
yeah, the handout I gave you. Not that homework.
No.
That's homework, not that. Ooh, can you hold it up? That right there.
Yeah.
That right there. That's gonna kind of help you guys study because that kind of hits on all the important facts, all the important things per parameter, guys. All right. So real quick, guys. Pat, what is period? The amount of time it takes to make one cycle. Okay, that's what the period is. What is our units of period? Myra. Microsecond, but any measurement of time, I'm good with that. Any measurement used with time. All right, Jasmine, can you tell me what is frequency?
Like how often it occurs.
Okay,
That's the way I understand.
Okay, I'm good with that definition. For
specific
ultrasound,
duration.
more specific with ultrasound. More specific with ultrasound. Number of cycles per second.
Oh, that's
Number of cycles per second. Okay. And remember, for frequency, our main units are going to be in hertz, but also, our main units are going to be in hertz. All right. So let's keep it moving. Let's move on over to the bigness parameters, guys. Amplitude, power, intensity. Okay. They all describe the magnitude, the strength, and the size of a sound wave. Okay. All right. So just to review. Where's my clicker? There it is. So. Okay. So again, amplitude. That's the big, long definition of it right there. But basically, it's the difference between the peak of the wave to the x or the zero on the x. Okay.
which is called the undisrupted, right?
The undisturbed area.
Undisrupted.
Undisturbed or average value on the graph. Okay. Or the difference between the trough and the undisturbed value. Okay. Remember, if you measure from peak to trough, that's going to be our peak to peak amplitude, right? Peak to peak amplitude. Okay. So again, with our units with amplitude, they're usually going to measure them in any one of the acoustic variables. So that can be pascals, grams per centimeter, kilograms per centimeters cubed, or any measurement of distance. But normally they're going to use decibels. Okay. But in this, when they gave us the typical values, guys, they gave the typical values in pascals. So pressure amplitude ranges, because also amplitude is also the amount of pressure. So that's what the on the Y. That's also the pressure of a sound wave as well. Okay. So our range is going to be 1 megapascal to 3 megapascals. Okay.
You have to know the range.
You do have to know the typical values. Absolutely have to know the typical values. Okay. Guys, all three of our bigness parameters, API, amplitude, power, and intensity, they're all determined by the sound source initially, right? Because we know as sound propagates that it loses energy, right? So if they, the question may say initially, but just for our own edification, it's always determined by the sound source. Okay, amplitude, power, and intensity are all determined by the sound source. Amplitude, power, intensity, yes, all three of them are also adjustable, right? All three of them are also adjustable. I've been doing tough research to find where can I change as far as the amplitude button. There's no amplitude button. I'm assuming that it has a relationship to do with the acoustic power button, right? Because that's changing that, because that affects the power. They also change the intensity. They all control the bigness of a wave. So I'm assuming amplitude, because as I was looking as well, because this has to be the sound we're sending out to the patient. Because you can also control amplitude with your gain. You control the amplitude with gain, but that's kind of like post-processing. That's after the sound has already come back, right? So amplitude, we're going to say that's the acoustic power button. I know some of you guys want to know what button is associated with changing the strength of a wave. That's going to be our acoustic power. Right? Remember, we practice our lower settings, right? As low as reasonably achievable. So we never want our acoustic power to be to the max. Right? We always want it to be to the lowest, because even though ultrasound is not technically harmful, you know, but ultrasound is still so young, they haven't discovered all of the long-term effects of diagnostic ultrasound. Okay? But ultrasound in higher frequencies, you know, it can be harmful, right? Because we know that therapeutic ultrasound heats up the tissues and causes cavitation, and it helps with healing, right? So we know that at a certain point, it can be harmful to cells. Okay? So, again, amplitude, determined by the sound source, and all three of them are adjustable. All of our bigness parameters are adjustable. Okay? We're gonna just say that's our acoustic power button, right? All right. So again, our amplitude is just measured from the baseline to the maximum value, or from the baseline to the minimum value. That's how we describe our amplitudes. Okay. All right. Peak to peak amplitude is the difference between the maximum and minimum values. So peak to peak amplitude is basically amplitude squared, right? Our amplitude plus amplitude, right? That's how we're going to get our peak to peak. All right. So again, it may be some numbers associated with this. So if my amplitude is 50, what would be my peak to peak amplitude?
Cody.
50,
100.
100, dude.
50.
100. 100. 100. Okay. All right. So again, peak to peak amplitude is twice the value of the amplitude. Sweet deal. Keep it moving.
So if you have 100 megapascals?
Whatever Pascal, whatever unit I haven't just, I'm not asking for a typical value in that case, but
Or is that an example?
yeah, that could be an example right there. It could also be 100 kilograms per centimeters cubed. It can also be 100 centimeters. So any one of those, any one of the acoustic variables, we can use that as a unit for amplitude. Okay. What are acoustic variables, Farnaz?
Distance, pressure, and
There you go. There you go. There you go. Guys, don't forget your acoustic variables, because you never know when I might spring them back up on you. I don't want you guys to forget. Never. I'm not gonna let you forget anything. Think back about last semester. All right. So power, guys, is the rate of energy transfer or the rate at which work is performed. How you learned it in real physics is, what the definition of power is, the ability to do work. That's the definition of power in normal physics. But when it comes to ultrasound physics, we're going to go with the rate of energy transfer or the rate at which work is performed. Again, power also describes the bigness of a wave. Okay? And power probably the most recognizable one to us, because we know power is associated with watts. Okay? Think about when you get that light bill every month, you're like, man, especially in the summer, 200 kilowatts? Oh my goodness. $200 bill in lights, unless you got solar panels, then it's different. Okay, so that's our units of power will be watts. Our typical values range from 4 to 90 milliwatts. 4 to 90 milliwatts. All right. Also, like I said, determined by the sound source, and it's adjustable. Remember, determined by the sound source initially, but as a wave propagates or as it travels, it's going to lose intensity. Lose strength. Lose strength. I don't want to use intensity because that's another parameter. But it's going to lose intensity as it propagates. But yes, it is adjustable, and for sure, power would be synonymous with our acoustic power, or the power we're sending to the patient. Okay. We're good on this, guys? Good on that? Sweet. Let's talk about how power is related to amplitude. Okay? So guys, this symbol right here, that means proportional. Okay? That symbol right there means proportional or related, right? Proportional also means related. Okay? So both power and amplitude describe the size, magnitude, or bigness of a wave. However, power is proportional to the amplitude squared. Okay? So an example it gives in the book. So my amplitude is 10, then my power would be 100. Okay? Because 10 squared is 100.
Oh,
right?
You said the amplitude is 10?
Yes,
No, but
Given an
isn't we
example.
supposed to square the
the amplitude.
amplitude? It's already squared.
No, you have to square it to get the power.
Oh, so
Got
they're
it?
proportional. Yeah, yeah.
Exactly, they're proportional. Again, that's what this symbol means, guys. Don't forget that. That's what that symbol means. Proportional. So my amplitude is, so if my power is 25, what is my amplitude? 5. 5 is my amplitude. 5 is my
So
amplitude.
you go vice versa. It's square
Okay.
root here in the
Yeah, exactly. Exactly. Just like that. Just like that. You know? You will have a calculator on the SPI. Not for class though, because I'm not gonna give you big complicated numbers, but you will have a calculator on the SPI if you happen to need one. Okay? So just know how to work that forwards and backwards, okay? Know how to work that forwards and backwards, okay? So amplitude, if my amplitude is, I don't know, 7, Sophia, what is my power? If my amplitude is 7, what is the power?
7 times 7.
7 times 7 is 49. 49. All right? So know how to calculate this math.
I think if our power is 7, our amplitude will be 49.
No, listen to what I'm telling you, Mr. C. I'm telling you. Power
Because
is
that's what I was
proportional to the amplitude squared. Okay? It's not the opposite way. It's not power squared is proportional to amplitude. All right?
Can I say something?
Yes.
Because that's what I was thinking at the beginning, because the number that we have, whatever number we have, like let's say I have a power for 5, I'm supposed to square it to get the amplitude. So how is gonna be the vice versa? Because here it's saying,
Okay, let's look at our example on page 30. Look at our example on page 30, right? A sonographer increases the amplitude by a factor of 3. How has the power changed? Recall that power is proportional to the amplitude squared. The amplitude is 3, right? And then it says, thus power is increased 9-fold because our power is now 9. You got it? You clear? What's wrong? You still not getting it? No?
okay, let's go. Okay.
Increase this
Can you give another?
You
The
got
power.
Okay, okay.
That power you find square root. And
Just
square
the
root
amplitude
square
to
it.
get the power.
That's it.
Yeah.
That's it. That's it. You double amplitude to get the power. You know, but I want you to know amplitude squared because that's also related to intensity as well. So that's why I want you to know that.
Okay, then if I have the power to get the amplitude,
It's the square root of the power.
if I have the amplitude,
You have to square the amplitude to get the power.
how is that gonna
Do you
be?
wanna, maybe you
Both
can use
ways
a
square,
number
so that means
Okay.
right now what we're doing, we're squaring both ways.
You're not squaring both ways.
Yeah, because you said to get the
I
amplitude.
said the square root of the power will give you
Oh,
the
square.
amplitude.
Yes,
The
okay.
amplitude squared will give you the power. Yeah.
proportional.
Okay.
Can you
Am I
write it for
confusing?
us?
All right, let's do one. Let's do one. Okay.
No, write the rule.
The rule
Yes.
is right there.